Then now we will discuss about what causes these irreversibilities. What are the reasons for these irreversibilities? What makes a process irreversible? The first thing is the friction. Then you have the unrestrained expansion of gas. Then you have the heat transfer across finite temperature difference. Okay, so there are several other factors, but these are the most important factors which makes a process irreversible. So we have already explained this point, heat transfer across finite temperature difference in the case of a Pepsi can. So in a Pepsi can, heat is transferred from a low temperature body to a high temperature. There is a finite difference, temperature difference. So we will see each one of them in detail. So the first irreversibility is the friction. So let us see why the friction causes makes a process irreversible. So you have seen a body here, and this is a plane, and this body can be sliding along this plane. So when it slides along this plane, you can see that there is a friction. Okay, friction on the surface. So that means there is a work done. See, when it moves, this surface is doing a work due to this friction. So what happens is that this body gets heated, and finally, if you sufficient time is allowed, this heat will be released. This body gets cooled. That means heat released to the surroundings Q. So you can see that. See, when it slides, that means a work is done on this body. So that means you need to supply work also. You need to push this body, and to push this body, when you are pushing this body, and a friction work is done on this body. So heat will be released from this body, and its temperature will fall down after some time. Now, see, in order to make this process reversible, that means, see, you can supply this heat back to this body to produce an equivalent amount of work. So this is impossible. This work can be fully converted to heat, but when you are trying to convert this heat back to this work, this is not possible because it violates Kelvin Planck statement. Because in order to produce this work, you need to supply you need to release heat to another reservoir. You cannot exchange heat with a single reservoir, that is the surroundings, and produce an equivalent amount of work. So that is why this friction makes a process irreversible. Now, second irreversibility is the unrestrained expansion. So let us see what is an unrestrained expansion. So here you have a fast compression process. So what happens in a fast compression process? That means this is not a quasi-static process. The region here gets compressed more. The region here gets compressed more than the region here. That means the pressure here will be different than the pressure here. This will be higher and this will be lower. So that means this is not an equilibrium process. This is not a quasi-static process. So same thing happens during a fast expansion. When fast expansion, the molecules here will not see, you will have less pressure here, okay, near to the piston, and you have more pressure here. Okay, this is the case of a fast expansion. So in that case also, it becomes, the process become irreversible because it, see, throughout this process the system is not in equilibrium. This is a non-equilibrium process. So this is a fast expansion. And then you have the unrestrained expansion. This is another reason. So you have fast compression process is one reason, fast expansion. Then you have the unrestrained expansion. In unrestrained expansion means if there is a slide, if you make a slide hole and if there is a gas here and gas pressure is 700 kilopascal, here it is a low pressure, then the gas will suddenly flow from this high pressure region to this low pressure region. So this is called an unrestrained expansion. And this is also a highly irreversible process, because if you want to reverse this process, you can push back all this gas to this area and increase its pressure. But during this process, the gas will get heated and it will release heat. Okay, so it will leave a trace in the surroundings. So that is why this unrestrained expansion is also a irreversible process. Then you have the finite temperature heat transfer. We have already seen the example of this Pepsi can. So this Pepsi can gets cold because it absorbs heat from the surroundings. So in order to reverse it back to its initial condition, you can do that, but in order to do that, you need to take in heat from the Pepsi can with the help of a refrigerator. This refrigerator works with the help of an external work. So when the Pepsi can comes back to its initial state, it will release a heat that is Q plus W into the surroundings. Okay, so that means heat is absorbed here and heat is released here, but in addition to that, this work is also released, this energy is also released into the atmosphere. Okay, that means it leaves a trace in the surroundings.